simplifying radical expressions. So when we are simplifying a radical expression, simplifying a radical expression means to rewrite it. Means to rewrite it as a radical, but pull some things out of that radical. But let's try to pull some things out. Let's try to pull some things out. And this can easily be done by factoring. Woohoo! Factoring, right? Comes back into life. Easier form of factoring. Okay. Not as complex as what we were doing in the previous test. So we're going to simplify this by factoring. Okay, we're going to simplify by factoring. And what I'm going to do here is I'm going to go back to the previous example that we just saw. We already know the answer, right? We did the problem. We know the answer. All right, let's go back. Let me refresh myself on that problem. This is the problem we're going to do. I want everyone to take a look here. This, I'm done. What did I do? Okay, we are going to take a look at this problem that we just did here, right? We already know the answer, but we did it by writing it as an exponential form, right? I'm not going to do it that way. I'm going to do it by factoring instead. Okay, everybody? So x to the power of 12, y to the power of 4, we know the answer, right? Square root x to the power of 12, y to the power of 4. All right, we already know the answer because we already did it. Okay, but we're going to do it differently. We're going to do this by factoring. Remember, we want to simplify, right? And according to the directions, according to what simplifying means, it says, hey, rewrite it. Rewrite it as a radical. Try to pull things out. Let's pull things out of it, right? We're going to factor. Very easy. All we're going to do is just break this up, right? Notice that my index is not present. Therefore, my index is 2, right? Index is 2. I'm going to make this kind of long. I'm going to make this long just because I got a lot of stuff in there. I mean, I got 12 X's in there, and I got 4 Y's. I'm going to write those down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 X's, Y's, 1, 2, 3, 4. Just break it all up. Factor it out, pull it all apart. Any questions there? Okay, y'all, this is where I want you to understand what we're doing. We look at the index. The index is going to tell us how we're going to circle. This index is 2, which means we are going to circle 2 of the same things. That's 2 of them. 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 Circle 2 of the same things. And for every 2, we just write it once. Right, we circle 2 of the same things, and for every 2, we just write it one time. And whatever we're left with, we're just multiplying them. Which means once we multiply that out, we're left with x to the power of, how many x's do we have? I see 1, 2, 3, 4, 5, 6. X to the power of 6, and I see 2 y's. Y to the power of 2. That is my answer. Which was the same answer that we got earlier when we applied it to different methods. Any questions? Any questions? A very nice example. Notice that everything in that radical was circled. Nothing was left. This is why we're not left with the radical symbol anymore. So now I want to go to this problem that is in red. Right? That I said, hey, can we do that? Right? And you're going to notice that with this problem, we can do it. And this is what you should expect majority of your problems to look like. All right, so let's take a look at that example. Okay, x to the power of 13, y to the power of 5. Square root x to the power of 13, y to the power of 5. Right, so once again, index is 2. I'm going to show it the same way. This time 13 x's, 5 y's. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13 x's, 1, 2, 3, 4, 5 y's. And yeah, there's more than one way of doing this. I kind of like to show this as a little introduction method. But if you see faster ways of doing it, by all means, go ahead and do it that way. If you have questions on whether or not the work is right, just show it to me. Okay? Because view an example will not show it this way. They'll show a different method. And that's okay as well. Circle in groups of 2s, right? I got 1, 2 of them, 3, 4, those, and even that one. Regards of y's, I got those, and those are the same. Remember, for every 2 that we circle, we just show one of them. And then we multiply that. So we're left with what? X to the power of 5, y to the power of 2. But notice that we have two things uncircled. And those that are uncircled stay inside the radical symbol. We bring our radical symbol back. Whatever is left with uncircled goes inside our radical symbol. So this is that answer when it is simplified.
That should be x to the power of 6, though, right?
1, 2, 3, 4. Thank you. It sure is. Very good. Right? We pull out what we can, and then whatever we can't stays in that radical. This is simplifying a radical. Y'all, we just rewrote it. Right? We rewrote by pulling some things out. Does that make sense, everybody? So this is what you'll be doing on your homework. I did 2 very easy problems because these indexes were 2. But what if the index was 4? That means you would circle in groups of what? 4. Take a look at another example. 4th root of 80 x to the power of 5y to the power of 9. And you'll see numbers within your examples, right? The letters are the easy part, but the numbers should be pretty easy too. All you got to do is break up these numbers. How do we break up these numbers? Well, let's just make a factor tree, right? Let's take a look at our 80. Let's break that up, right? And just divide by a small number. What's 80 divided by 2? We get 2 and 40. If 2 doesn't work, try 3. If 3 doesn't work, try 4. Just try small numbers. We can break up 40, right? Divide that by 2 again. That's 2 and 20. Right? Break up 20. Well, that's 2 and 10. You break up 10, that's 2 and 5. So we just broke up this 80 to all these small numbers. 2, 2, 2, 2, and 5. Make sense, y'all? And this is what you'll see. You'll see a lot of problems that have numbers. So now just rewrite it. Make this a little longer. Now I show those numbers in there. Right? I got 1, 2, 4 2s, 1, 2, 3, 4 2s, and then I have a 5. And then in regards of x's, I got 5 of them. In regards of y's, I got 9 of them. So I really just factored out that inside, just broke it up completely. Any questions so far? Any questions? Okay. Circle 4 of the same ones. Now it's 4 of them. 4 2s. I just write 1 of them. X's. 4 of them. I just write 1. Y's. 4 of them. I just write 1. Y's again. 4 of them. Just write 1. All right, we multiply that, what we're left with. So that's 2x y to the power of 2. Bring my radical symbol back with my index. What was left uncircled? Oh, a 5, an x.
5xy.
Very good. And that goes inside my radical symbol with that 4th root. And we were able to simplify that by factoring it out. Any questions, y'all? Any questions? So you'll have some nice examples to work on. I wanted to do a few just to get you to understand it. And once again, there's more than one way of doing it. I think this is a nice visual way of doing it. Makes it pretty easy. But if you view an example, they'll show you another method. And you can also do it that way if you like to as well. Whatever works for right. Moving on. Moving on. We can also multiply these examples and factor them. But it's the same idea, right? So let's take a look at some examples where we multiply and simplify by factoring. Let's take a quick look here at something. Mhm. So when we are multiplying and simplifying, um, let's state something. Let's not use the word example yet. Okay, let me take that off. All right, to multiply and simplify by factoring, the index of each radical must be the same. Right, the index of each radical must be the same. Right. The general form tells us that if we have the nth root of a and we are multiplying it by the nth root of b, then we can multiply the radicans, keeping that index the same. So as long as the indexes are identical, then we can multiply. Right? The indexes must be the same in order for us to multiply them. So now let's take a look at an example. Square root of 21 times the square root of 6. So notice that both of these radicals have an index of 2. Therefore, we can actually multiply them, right? This should be index of 2 of 21 times 6.
I have a question.
Yes.
How do we know it has an index of 2?
Because if an index is never present, right? If an index is never present, it always implies that the index is 2. Right? So very good question. Just remember, y'all, and I think we talked about this in 6.1, and maybe some people missed that. But if an index is never present, it implies it's 2. Just like this. That really means that the coefficient is what? What's the number in front of that letter? 1. If it has no exponent, it really means that the exponent is what? 1. Right? So with the radicals, if we have something like this, that really means that the index is 2, because we're used to seeing that radical symbol. That radical symbol we call square root. Square always meant 2. So when it's not visible, it means that it's 2, right? That 4 has no exponent, so it really means it's 1. So does that make sense there?
Yes.
Good, yeah. So
Thank
anytime index not present always means it's 2. And it's going to be very important, y'all, to understand that moving forward, because that's going to come back. First of all, I was in 6.1. It was in 6.2. It's in 6-3. We're going to see it in 6-4. You're going to see it in 6-5. You're going to see it in 6-6. You're going to see it in 6-7. So very great question. Let's not forget that. All right. So let's continue here. We can multiply 21 times 6, right? But instead of multiplying 21 times 6, because 21 times 6 gives me a big number. Let's just break up 21. So what times what? 3 times?
3 times 7.
Let's break up 6. So what?
3 times 2, or 2 times 3.
2 times 3. So now these numbers, I'm just going to put in there. And I'm going to kind of pair them up, right? I'm going to put my 2 first, then I'll put my 3s next, then I'll put my 7 there. So instead of multiplying 21 times 6 to get a big number, why don't we just break up 21? And why don't we just break up 6? A lot nicer, isn't it? And now here we're just pulling in groups of what? 2. Index is 2, right? So we can pull that 3 out, right? What are we left with here? We're left with now a 2 and a 7, and just multiply those. Leaves us, right? You don't have to show that middle step. You can just go for 3s left on the outside. You can multiply those in your head if you want to, right? Leaves us 14.
So when you pull it out and you multiply it, you remove the index.
Correct. And very good. You know,
on the other one, you did it.
We never show, so an index of 2 is never shown in the answer.
Oh, it was 4. So if it's more than 2, then you would show whatever it was.
Correct. An index of 2 is never shown in the solution because when there is no index, it implies it's 2. The only reason that we put that there is to help us understand that we got to circle in groups of 2s. Right? We just put that there to help us. Oh, I got to circle in groups of 2s, but the final answer, we won't show that to you. Because if you show it 2, it's going to say it's wrong. But if you show it me on the test, I'm going to give you most of the credit, right? I'll probably give you, a 98 or a 99 on that problem if everything is perfect. Because to me, I'm more concerned that you can do everything else, and I'm not too concerned about that too. Make sense? So, very good, very good. Other questions with this example? Let's do one more example like that. Example B, right? How about the third root of y to the power of 10 times the third root of 16y to the power of 11? And once again, I'll be reviewing these problems tomorrow too in person, y'all. If y'all wanted to come sit in my 11 o'clock class or 12:45 class, I'm be doing these exact problems again, face-to-face with students. You're more than welcome to join. The nice thing about this example is they both have the same index, right? So now this is the third root of y to the power of 10 times 16y to the power of 11. Right? We can show these two radicals as one radical now. And now I'm going to go ahead. I want to see the 16 first. I'm going to show that first. Right? I'm going to show my 16y to the 11 first, my y to the power of 10 second. And now all you gotta do is break up your 16. Many of ways of doing it, but 4 and 4, right? And then these 4s are just in 2s. Make this a little longer because I got a whole bunch of y's. But I got 4 2s. You can show the multiplication symbol or not if you don't want. Either way is fine. 11 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 y's. Then I got another 10 y's. 2, 3, 4, 5, 6, 7, 8, 9, 10. Any questions here so far, y'all? And now we circle in groups of what?
In groups of 3.
Very good, right? So we have these 3 2s. 3, 3, 3. Those 3, 3, 3, 3. We have 2. Y, 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 and y. So remember, for each one of those circles, we show one of those. Here's a 2y to the power of
7.
good. Bring your radical back with the index of 3. We want to show the 3, right? What's left uncircled?
2.
Oops. Very good. So that goes inside. Any questions? Any questions? Alrighty, a few more examples to look at. Let's go ahead and take a look at some division ones that we can simplify. Anyone need another minute copying this down?
I'll need a minute.
Okay, just let me know when you're done, please.
I'm done.
All right. So dividing and simplifying. When it comes to dividing and simplifying these radicals, if we have a fraction as our radicand, we can always rewrite it as 2 separate ones with that same index. So if we have one radical and inside we have a fraction, we can just rewrite it as 2 separate ones. So let's take a look. Square root of 35a over square root of 7a. So if we take a look at this example here, it kind of looks like this side, where we have 2 radicals. So why don't we make it look like 1 radical? Notice that they both have the same index. Index is 2. So we're going to show it that like that. That means 1 radical, 1 fraction. 35a on the top, 7a on the bottom. And can't we simplify that?
Yes.
Well, what do we have here? A on the top, A on the bottom, cancel out. What's 35 divided by 7?
Uh,
There you go. So we're left with square root of 5.
Hmm.
All right, very nice example there. Any questions there? Well, what about example B? Square root of 64y to the power of 7 over x to the power of 8. Well, now, if you take a look at this example looks like this. So now, let's make it look like that. Show two radicals, one on the top, one on the bottom. Both those radicals are going to have an index of what?
2.
2.
Good. Index is not present, means it has an index of 2. So now on the top, square root 64y to the 7. On the bottom, square root of x to the 8th. And remember, we're just showing this to help us with the work, right, everybody? And I would just break these up, right? You work this out now. All right, you can break up your 64, right? Break up your y's to the power of 7, x to the power of 8, right? Break it up completely. All right. What times what gives us 64?
8 times 8.
Hey, look, I'm just going to stop there because it's two of the same things, aren't they? You can break it up further if you want to, but hey, I already found two of the same things, right? Then I have all these y's, 1, 2, 3, 4, 5, 6, 7 y's on the top. In the bottom, you have your x's, 1, 2. You can do it many ways. 2, 3, 4, 5, 6, 7, 8. And you just start kind of pulling out. 8 comes out. Y. Now we're pulling in groups of 2s. So the top should be 8, y to the 3rd, square root of y on the top. What are we left with on the bottom there?
X, y,
X to the 4th.
Good, x to the 4th, right? We have that pull out, leaving us with x to the 4th. And there we go. We divided and simplified. Any questions?